Great.
Yeah.
Yeah, so today our topic is RAG over evolving enterprise knowledge. We're going to talk today about how to get changes that your organization is constantly making to your source knowledge and get that into your destination blob storage or databases or vector stores and do that in a very efficient and cost-effective way. Next slide. And so today, my name is Paul, and I work on the technical documentation here at Unstructured. I also work on our code examples, sample notebooks, and I also do some training both on site and online. Jay, tell us a little bit about yourself.
Hello, I'm Ajay. I work as a developer advocate with Unstructured. I write a lot of blog posts. I write a lot of notebooks. You're gonna see me like always on LinkedIn, doom scrolling all the time. And apart from that, yeah, like it's really chill. I like yapping and I like making sure the content I put out is like trying to like is at least helping somebody in some concept or another. Yeah. So nice to
Yeah,
be here. So nice to be doing this today.
yeah. Jay and I both work on the same team, and it's really fun to be able to bring content like this to you today.
Yep. Yep.
Next slide. So let's talk about more about our subject today. I'm going to spend a few moments bringing folks up to speed, especially those who are new, about who Unstructured is. And then Ajay's going to let us know a little bit more about our topic today, including the importance and of connectors and how important they actually are. And then we're going to talk about how to get data into Unstructured by using those connectors and do it in a way that's both cost effective and highly performant. And Jay will lead us through a demo today and showing you all of this in action. So let's get going. Housekeeping, if you have anything you want to communicate to us or to other folks who are participating in the webinar, be sure to do that in the chat. If you have questions for Jay and myself, please put those in the Q&A portion panel, and we will get to those as we have time. And folks, you almost always ask in these recordings, will there be a recording afterwards? And the answer is always absolutely. And we'll send them to your email after we wrap things up today. And then POC stands for proof of concept. If you would like us to come in and do a demonstration or more importantly, do a proof of concept to show you how we can actually use unstructured to convert your documents and data into AI-ready content. We're happy to schedule a one-on-one chat, and we'll give you the links on how to do that at the end of this presentation. So who are we? If you're joining us for the first time or haven't been here for a while, just share a few numbers with you. We have over 10,000 paying customers who are using Unstructured today. We started as an open source product and have added a lot of really great features to that open source product. We love open source, and it's appropriate for some customers, but most customers are finding lots of value in using our paid product, and we have over 50 million product downloads to date. Over 65,000 organizations are using unstructured today. And so if you decide to use unstructured or adopt unstructured for your organization, you are in good company. And we've been raising lots of money so that we can bring these great features to you. As you can see, we've won many awards and have many, household names, I guess you would call it in the tech industry, who are standing behind us and see the value in what we're doing and have partnered with us, and we're partnering with them to bring these holistic solutions to you today.
So
So, so let's go ahead and I'll turn it over to you, Ajay, and you continue on with our presentation.
totally, totally. Thank you so much, Paul. So let's get into the meat of what we're discussing today. What should a document processing system do? What are the functionalities that you think, they should do? I'm asking this to the chat. So if you have any like certain requirements that you think a document processing should system should do, feel free to post them in the chat. We'll talk about it right now. True, true. It should parse PDFs and a bunch of other documents. True. It's right there. Correct. Anything else? Hmm. Yeah, that is also correct. Yeah, that's true. It's like you have a bunch of documents and you might want something custom, and maybe instead of like you having to write separate Python plugin codes, you might expect extra work, like additional metadata that can just come through right out of the box. That's nice. I'm also thinking about a bunch of other features, maybe. Firstly, it should give you clean and normalized text in the sense that you give it an input which is of any file type, and it should give you something in a very standardized format. It should be able to extract a lot of tables and images because all of these data, like tables, contain a lot of structured data, and that usually gets lost if we are trying to translate by this naive text. Same with images. We need like images have like there's a lot of graphs, there's a lot of other descriptions or like other nodes. Like like if you could just fetch from a graph like image itself. And then it should also be able to handle complex layouts. It should be able to handle nuances in the data you see itself. Like if the data comes from a particular domain, or if it has a lot of like weird looking tables, scary looking tables that even we find it hard to register in our heads. And then maybe a bunch of other features like being able to chunk your data, being able to generate embeddings for this data, all that. And yeah, that's true. Like all of these, like in my head, yeah, these are all like valid features, but and we also see this all the time in every RAG tutorial. But there's also something that I want to highlight here, something very important that usually gets missed out. That is connectors. All of this parsing, chunking, embedding work, all of this won't matter if you actually cannot get your data from your source system into the document processing node in the first place. And all of this also does not matter if you cannot deliver your processed results into a database or your destination. So this is what, when you think about a full pipeline, this is a lot of times what it's going to look like at a high level. You're going to have your data sources in the left, which can be a SharePoint, a Google Drive, S3, and so on. And then you're going to have a destination on the right, which can be like your GraphDB or a VectorDB, any database. And these connectors are what bridges these gaps. Like they're in my head, they're these pipes that move data from source, process it, and then move it to the destination. And I think they're really underrated. So why they're underrated is just that if you are thinking about a connector, you also need to make sure that it needs to pull data reliably from different platforms. And all of these platforms can have their own API, they have their own quirks, they have different rate limits. If you think about it, Google Drive is going to be very different from AWS S3, and a connector needs to abstract all of that for you. It needs to securely transfer these files. Enterprise data is really sensitive, so you need proper authentication, encryption in transit, handling all of these credentials. This isn't going to be trivial work. And then there's also other features like being able to detect what is changed, making sure your processing is very efficient, and being able to like handle failures and retries, and also just managing authentication itself because there's going to be like different sources can require different authentication methods, and each connector should be able to like handle all of this smoothly, and you shouldn't really like think about all of these when you're processing documents. So in this field, at least, like from what I've seen, we often talk a lot about parsing accuracy as we should, but I think connector reliability is also something that's really important because that's what's also going to determine how your system works in production. If you're not able to pull data into your system to like do all this processing work, then you're not even getting started. So I think connector is really important, and we often end up skipping it, but just highlighting it again. So today's focus is going to be on one specific aspect of connectors itself, which is what happens when documents change. If we think about any organization, there's going to be a bunch of policies. These policies can get updated regularly. There is sales tax and they can get revised every couple of months. You have documentations that get updated all the time, other knowledge base articles that can get corrected. So, in a living enterprise, your documents aren't static. They are going to evolve, and your RAG system also needs to evolve with them. So, the question here becomes, how do you keep your system without breaking your wallet or without waiting for hours for all of these documents to like reach your destination and the updates to be successful? So, to answer it, we're gonna look at two approaches for this. So, let's look at the first one with a scenario maybe. This approach is called full reprocessing. So the scenario is that I have like 300 documents that I've already processed and indexed. Everything's working fine. Now I'm gonna add one more document to my Google Drive. With full reprocessing, now we process all 300 plus this new file from scratch. I'm gonna spend 2 hours doing it. And I'm also gonna spend around like 450 bucks on compute and API. And there's a lot of like, yeah, I just spent 450 on all of this. So this approach is really simple. It's very straightforward if you think about it. And it makes a lot of sense when you're dealing with a small document corpus, say you just have like 100 pages or so. Or if you're on like initial experimentation, maybe you're trying to figure out which parser works best for you, which chunk settings work best for you, what embedding model, and so on. Or maybe you have like a new metadata field you want to add. In that situation, full reprocessing makes a lot of sense. But there's also places where it can fall apart. And to show you, like, to convey the exact reason why it can, here's just one single meme. So, yeah, pretty much. Like, you just added one file, all of your other files are not haven't really changed. So why bother processing all of your previous files all over again? This isn't going to work exactly when you're dealing with like 10,000 or 100,000 documents and you're just adding like one single like new document. You don't really want to pre-process everything a day. And then this is also not going to work when you're dealing with like daily syncs. For example, if your data source is pulling data on a schedule every night, then full reprocessing means your overnight job is just going to get longer and more expensive over time. Yeah, this was overall is going to get more expensive. It can take a lot of time. And for these scenarios, we're going to think about something smarter. And that's where the second approach comes in, incremental sync. It's pretty simple, very intuitively. It's really just in the same scenario. When I upload a new document now, I just process that one new document and carry on. So I just processed the one new document instead of the original 301. I spent 2 minutes on it and I spent a couple of quarters on it, and that's all. It's all done. So this makes a lot of sense. Like this works really well when you have thousands of documents and maybe, like 1 or like 2% of it is changing. Works well in your nightly sync situations. Basically works when you have a lot of data, your scale is big, and you're also like adding in new documents regularly. And this sort of like this works when you need to like keep your rack system continuously current and also make sure the process of keeping everything current is economical and efficient. This can like not might not be the best option if you are like trying to understand like which configurations you need to use in your system or you're just doing one-time migrations. But overall, both of these approaches have their place. Like full reprocessing works. It's very simple. It works when you're just starting out. Like we've seen usually full reprocessing work when companies are just starting out and they want to like align on the set of like configurations they want to use, maybe the chunk size, like the different metadata, the parsing technique, and so on. But beyond a point, once all of those settings are all set in stone, you're just adding new documents daily. And in that situation, incremental sync just works fine because your old documents aren't changing. You're just adding new documents, and that's it. So now that you've seen how this works conceptually, let me show you how we go about it or how we implemented it in unstructured. So our core intuition was just built on these three principles. Firstly, we want to make sure that incremental sync should prevent duplicate processing. It's really like it's obvious, like the sentence looks really obvious, but getting it right is a little bit tricky and annoying because you need to maintain state of which documents are processed. So you need to like definitively answer the question, hey, there's like 100 documents. Have all 100 documents been processed already? Or are there new documents that we haven't processed? Or did we make any changes to these documents? So do we need to reprocess them again? And then secondly, your database should not get polluted. If you process the same documents twice without cleaning up, you're going to end up with duplicate chunks in your vector store. This can degrade your retrieval quality. And thirdly, you also want to make sure this whole process is efficient. Because if it's inefficient, you're going to like drive up costs. So if you're going to reprocess a bunch of old documents, you're paying more money. So all of these are simple ideas, but implementing them reliably across a bunch of different like connectors is where the complexity starts coming in. So when it's all implemented and done, and when you're seeing it in action, this is what this whole flow is going to look like. There's a lot of boxes, there's a lot of arrow marks. Don't really think about all of it right now. Just focus on my mouse alone as I explain. So when the sync runs, we start at the source files. We first check if we've enabled reprocess all, or like we've enabled incremental sync. If we've not enabled incremental sync, that means we just identify all the documents, reprocess everything from scratch, throw them into the destination. If like we've enabled incremental sync, then we check each file. Each source connector has a certain tell, a certain metadata to it, which helps us determine if this file has changed or not. So if this file hasn't changed, we skip it. If this file has changed, we extract, we process, we do all these steps on it, and we send it to the destination. So that's kind of like how all of this works in action. And what happens in the destination itself, if you think no. So again, we also just spoke about how your retrieval quality should not get affected, right? So then at the destination, if it's a vector store or a database, we are going to perform this delete and insert operation. So we first delete the old data associated to that document if it is already present, and then we insert the newly processed data. So now this ensures that you're never going to have any duplicates, and you're also never going to lose data during the updates. So this whole process now becomes very atomic, very clean, and your document is now either fully updated or it's not. Now, we've seen all of this like in theory, and I also showed you how this looks like how we've implemented it at unstructured. So now if you want to go ahead, throw a bunch of documents into your pipeline, play around, here's a quick demo for it. So I created this small workflow at the unstructured platform. What's basically going on here is that the data is all stored in this bucket in AWS S3. This All this data goes through a bunch of steps, gets converted, gets processed and converted, and then gets pushed into Astra DB. That's it. So like each of these steps can take me like 1 minute or more. So in true demo fashion, I've just like pre-ran these results and I just kept it right now. So initially I just processed 90 documents and stored all of them in Astra DB. So if I wanted to look at how it all went by, just basically 90 files were structured, which meant in the source connector detected that 90 files were new and have not been processed at all. So all of these files got processed and they got pushed into the destination. So now I wanted to add an extra document, and I also wanted to make sure that I didn't really, like reprocess everything from scratch. So all I had to do here to enable incremental sync was go to settings in my workflow, uncheck this box, run it, and I saw these results. So here 91 files were structured, but if you remember in our previous workflow, we had 90, but here there's just one file that is structured, which meant our source connector did the job of seeing which file is processed or wasn't processed, took the only file that wasn't processed, and put it through all these steps and threw that into my database. The same thing happens even if I want to update it. So I just updated the same document. I reran it. Same thing. 91 files, but only one file is taken. All these steps happened and got pushed into the destination. As to how the data looks like in the destination itself, Yeah, so initially when I first added the new document, there is only three chunks, and then I added like more content into it, pushed it back into S3 and reran the workflow. And now it has like five chunks. But if you notice, you can also see the whole delete and insert pattern in action. The ID column over here is changed from the first image to the second image. So we deleted the original existing IDs and then we reinserted the new ones. So that's just how simple it is to enable incremental sync in your platform. You like in your workflows, you do not really have to go through the pain of coming up with a scalable method, making sure it works, like making sure, like everything like fits in the end into the full pipeline and running it. All of it just comes pre-packaged in. So just check a box, uncheck the box, and you're all done. So yeah, that's pretty much what I wanted to talk about today. So let's do a quick recap, which is that connectors are extremely underrated. They handle a lot of critical infrastructure like change detection, security, efficiency, and we often overlook it because we always think about parsing accuracy. But when you're also evaluating building like a document processing system or just like choosing a document processing platform, think about the data sources it can reliably connect to as well, because that's going to save you a lot of security or compliance headaches. Secondly, we do processing in like two methods to keep systems current. We do a full reprocessing approach or we do an incremental sync approach. And yeah, the result from all of this is that your enterprise RAG is now going to stay current always. It's not going to burn through your wallet and it's not going to make you wait a bunch of hours for updating whenever you add a new document. So yeah, like we do these webinars every alternate week. So if you have a different topic in mind, feel free to like ping me on LinkedIn or feel free to like email us, talk to us anywhere, and we'll be sure to like talk about it over a different webinar. But yeah, like we also have recordings available for our previous webinars. The last one was on how to build enterprise ready RAG systems by our solutions team. You can find it there on YouTube. Our next one is about unlocking your data with agentic RAG, where we talk about how agentic RAG can be used in enterprise. Register, come on, and we'll have a conversation about like how which pattern you could follow in enterprise. So yeah, now I'm just going to open it up for questions. If you have any, feel free to drop them over in the Q&A box, and me and Paul will try to tackle as much as we can. And while you're thinking about questions, if you also want to have if you have a specific use case you need our help with, or if you want to talk about, like how you could apply unstructured into your workflow, feel free to like schedule a guided POC with our team. We'll reach out to you and we can get things going.
Great, thanks, Ajay. We've got a few minutes left, and we've got some questions coming in. First question is, how soon after I update a file will that update actually show up in my vector store, say AstraDB, for example?
That's going to depend on that's going to depend on the schedule you're probably running it with. Like either you could automatically set a schedule because your file gets uploaded, then it's in your source like data store, which means when we run a next workflow, your source connector is going to detect that this file has been updated, or been added. So it's going to go through all of these steps. So yeah, it's going to depend on how and like what schedule you're running it on. Or check out like the notebooks itself. There's a bunch of like different tutorials on how we can use the API to trigger workflows whenever we want based on different conditions. Yep.
That's great. Thanks. Another question, do we have to change anything in how we connect to the database in downstream applications?
Uh, yeah, so not really because nothing's really changing. Like your connection still remains the same, irrespective of whether you do a full reprocessing or incremental sync. Like the hard work of pushing all of this data is handled from unstructured end. In your end, in terms of using this data, you're still doing the same thing, which is connect to the database normally, do a query, and get the responses and use it for your downstream RAG application. There's no change.
Great. Let's see, here's another question. When updating changed records in a vector store, for example, How does unstructured actually determine which specific records to delete? I think you covered this earlier, but maybe we could review that again.
Yeah, so this is going to depend on this is going to depend on the file itself in the source. So there's certain metadata we use to determine if a file has been newly modified or has been newly added. So based on that, we identify the file and then delete all the related chunks from that file from the database, and then reinsert the new chunks.
Does that change? Another related question, does that change based on if the destination is, say, S3 or Azure Blob Storage as opposed to like a vector database? How does that update work?
Nice question. Yeah, so if it's a vector store, this delete rows and insert pattern happens. If it's a blob storage like S3 or Azure, you're gonna like the entire old version of the file is going to get deleted and it'll be replaced by a newer version of the file.
Okay, great. And I'm sure that differs on a, case by case basis.
Yeah.
Each destination or is going to implement that differently. Good.
Yep.
Well, we are just about at time. Again, we want to thank everyone for attending today. And if you're watching this later, we hope you have learned something here. Again, we just really want to reach out to anyone who wants to use unstructured. There's the URL there. Contact our sales folks. They'd be happy to set you up on a proof of concept. Or if we can just answer any questions that you might have, just contact our sales team. They'd be happy to help you. But for now, I think that's it. Thanks, Ajay, for a great presentation, and we will see everyone next time on the next webinar.
Thank you so much, Paul. See you guys next time. Bye bye.
Bye.